Hello, everyone. Welcome to today's presentation. Happy Wednesday. I'm proud to announce Safety First will be our presenter, Michelle being the one speaking today. A few things about today's presentation before I pass it off to Michelle and she gets going with the slide deck. First of all, this is AIA accredited. So if you hadn't already submitted your number, I will drop a link in the chat. It'll be the first link where you can submit your registration number to receive credit for today's presentation. The second thing is that we have the Q&A at the bottom. So any questions that we have time for at the end, feel free to drop them as you think of them in the Q&A or chat them as well, and then we will get to those. Lastly, we'll be launching a webinar poll about 3/4 of the way through the presentation. Really great way to connect with Michelle after today's presentation in regards to things like samples, price quotes, product literature, or even if you would like an in-person office visit. One more thing before we get into today's presentation, I will show you how to connect with safety after today's presentation. First thing you can do is go onto Acelab. I'll also include this link in the chat. And then this is where you can give company information and the type of meeting you're interested in. Feel free to request things like office lunch and learns, CEU courses, etc. And the final link I'll be dropping in the chat will be where to find Safety First brand page on Acelab. Has really great information about their products, a bunch of spec sheets, and some really great case studies and inspiration at the end. And I think that's everything. So I am going to stop sharing and pass it off to Michelle.
Great, thank you. Let
Yeah.
me know when it is up and ready to go.
I see it. A-okay.
Okay, great, thank you. Thanks everybody for joining us. My name is Michelle Murray. I am the architectural sales rep for Safety First. And today we're going to do the innovative design applications using advanced fire-rated glazing. As Alyssa mentioned, this is an AIA accredited presentation. So all the material is copywritten, but if you do want a copy of it, we're happy to send that to you. We have 4 learning objectives today. We're going to look at the history of fire-rated glass from where it started to kind of where it is today, understanding the difference between fire protective and fire resistive glazing. And if there's any takeaway from the presentation, it's really objective number 2. It's learning about those 2 differences of glazing. We're going to look at how the architectural community's demand for larger sizes, better clarity, how it kind of drives what we do as a manufacturer, and then understanding the importance of a multifunctional glazing. That being, it's fire rated first, but has other additional performance characteristics such as hurricane, blast, ballistic, and we will look at case studies. But first, let's look at the history of fire-rated glass. The old solution was pretty clear cut. It was opaque. You didn't have views. Some of the older technology also wire glass and then ceramics. And the problem with wire glass and ceramics is that when it's used indoor side lights, hazardous locations, it has to be laminated or filmed to make sure that it can pass the current safety standards. 2 categories that were established back in 1977 are the 2 listed there. The first is the CPSC 16 CFR Category 1, which basically says that the glazing area, if it's less than 1,296 square inches, needs to survive the impact of basically a small child running into the glazing. It's 150 foot-pounds. If the opening is larger and it's greater than 1,296 square inches, at that point it needs to survive the impact of an adult. So 400 foot-pounds, it needs to have that impact resistance. And as the technology has evolved, you'll see the solution on the left, a clear specialty fire protective glazing. It's a nice crisp look versus the laminated ceramic where you get more of an amber tint, sometimes distortion. And then on the right, you'll see even larger, clear, transparent fire resistive glazing in larger sizes. So the evolution really has come a long ways. We also look at multifunctional, and we'll go into more detail during the case studies, but having a fire resistive or fire protective glazing with other performance characteristics such as those listed below. So where can fire-rated glass be found? It's in a lot of places that you probably think about, and then some that you don't. So fire doors, fire openings, or windows are pretty common areas that you'll see fire-rated glazing. But we can also be in walls and even in floors. So again, places that you would expect it and also not expect to see it. So learning objective 2 is just really understanding the difference between fire protective and fire resistive. Two things that you should know is that there are just these two categories. On the left, you'll see fire protective. These are typically openings such as windows or doors that are less than 45 minutes. On the right, fire resistive is considered a wall assembly. So the IBC distinguishes these two by the following. So a fire protective opening needs to contain the smoke and flame. And it's, like I said, typically 45 minutes or less. It needs to pass NFPA 257, 252, or UL 9, 10B, or in Canada, 10C. On the right, you'll see the fire resistive wall assembly. And basically, that's a transparent wall. It needs to contain the flame, the smoke, and also block the radiant heat. And typically, those openings are over 45 minutes. So the best way to understand this in pretty simple terms is if you have to block radiant heat, you are considered a wall assembly. So anything over 45 minutes needs to contain flame, smoke, and block that radiant heat. So how does a piece of glass get its endurance rating or its fire rating? The first thing it does is it goes through a fire endurance test. And this time it's in a furnace. It gets up to over 1900 degrees Fahrenheit. If the glass stays in the opening, it's certified for a particular fire rating, anywhere from 20 minutes to 3 hours. If it's going to be a fire resistant rated glazing, again, blocking that radiant heat, it also must limit the temperature rise to less than 250 degrees. So after the fire endurance test, that specimen is taken out and it's flipped around and it goes through what's called the hose stream test. Now, this isn't a thermal shock test. This is actual a structural test. Um, the water's delivered from 20 feet away at 30 psi. ASTM E119 and UL 263, you cannot have any glazing loss. So that glass must stay in the opening 100%. NFPA 257 does allow for a 30% separation at the perimeter and a 5% at the center. Most, not all fire rated glazings require this hose stream test. Typically, a 20-minute door light does not need to meet hose stream. North America and Canada, North America, so it's the US and Canada are the only two countries that still require that hose stream test. So I've talked a little bit about radiant heat, but what is it? So the radiant heat are electromagnetic waves that pretty much are traveling through the air. Well, they're not impinged by anything, but if it hits an item, so if that hit the electromagnetic wave hits an item, that energy converts to heat. And if that item that it's touching is flammable, that can cause spontaneous combustion. Now, this is just a radiant heat comparative test. These three different types of glazings are shown to show you how radiant heat can affect a human. Now, these are not fire resistive assemblies. This test is not showing failure of the glazing. It's just showing the limitations of what a fire protective glazing can do. So it's not blocking the radiant heat. So within 20 minutes, spontaneous combustion has occurred. This is a fire resistive test. This is showing glazing that's tested to ASTM E119 UL263. This is the wall criteria. So basically this is a transparent wall. Again, showing how the glazing and the frames can block that radiant heat. So again, just to recap, a fire-resistive glazing is defined as meeting the fire endurance test, the radiant heat test, and the hose stream test. Again, that will give you your ASTM E119 or UL263 standard as a wall assembly. So in the market, there are two types of fire-resistive products. On the left, you'll see two pieces of clear tempered glazing with an intumescent semi-solid fire retardant inside of it. And then on the right, you'll see what is called a multi-laminate. It's annealed glass, and in between the layers of glass, you have intumescent fire retardant layers. They're both going to serve the same purpose. And how it works is the glass is exposed to a fire. It's an omnidirectional, so it doesn't matter which side. By design, the light of glass towards the heat source will break and it will activate that inner layer, turning it into a char. The glass temperature remains low on the non-fire side and that radiant heat is blocked. If you have a wall assembly, you need to have a fire-rated glass with a fire-resistive framing. And again, you can see in this slide how on the fire side, the light by design breaks and it activates that interlayer. Learning objective theory, we're going to look at the demand for larger sizes, some optical clarity, thermal performance. These are a couple of case studies. This is 520 West 20th Street in New York. And this project was a mixed-use building. The top part was added on. Property line proximity mandated that the one side of the facade needed to be fire rated. When this was actually designed, they had smaller lights in there. Manufacturing was able to facilitate the project with larger sizes in a 2-hour fire resistive assembly. Each panel is 11 foot by 5 foot. And they were able to keep their unobstructed views of the Empire State Building. This is the Starbucks Reserve Roastery in Chicago. This is a former Crate and Barrel store that was converted into the roastery. It was important that visitors had a good experience. This is the 6th Starbucks Reserve Roastery. They opened up the staircase. These are 2-hour fire resistive assemblies into the stairwell. They commissioned an artist to paint, and this way they had the view into the staircase. It also allowed visitors to access the floors instead of using the elevators by using the staircases. You'll notice that this is a butt joint application, and I'll explain a little bit about the butt joint options that are available. These are 10-foot, 90-minute temperature rise doors. Okay, we're going to look at some optical clarity. This is the Harvard Business School, Klarman Hall. This is a new 1,000-seat auditorium and gathering space. The 2-hour glass wall that we'll see separates the lobby from the auditorium while providing a visual connection between them. The 2-hour fire resistive assembly used low iron glass with a VLT of almost 90%. The glass walls were segmented in plan. The profile is a 2.5-inch slim profile to mimic the look of aluminum storefront. These are 90-minute full vision doors, custom hardware. This is important. The college wanted the two spaces to be connected with a visual connection. This is the University of Wisconsin School of Business Learning Commons. This is a staircase that was reimagined. Typically, they're dark and tucked away. This project used clear but glazed fire-resistant walls. Those are 9 feet, 60-minute doors, aluminum clad. This project is a clear butt glazed wall versus a black butt joint wall. This is the Waste Management headquarters in Houston. This is a 2-hour stairwell that's kind of the focal point of a 9-story living wall. The panels are 9 feet by 4 foot wide with a clear butt joint. And this project used ultra low iron for maximum clarity. This is a fun application. This is the Porsche Design Tower in Florida. This is a 60-story residential condominium where cars are brought up into the sky garage using a glass elevator. The elevator shaft requires the enclosure to meet a 2-hour fire resistive. Residents stay in their car and enjoy the oceanfront view as they're brought up to their units. This is incorporating high performance glazing and fire resistive. This is the Aspen Art Museum in Aspen, Colorado. This was a woven wooden shoji screen. There is an exterior elevator, and the architect wanted to incorporate that into the facade. They need to be 2-hour rated. Since it's exposed to the elements, it needed to meet the same thermal criteria as the non-fire rated areas. Thermal analysis was performed, dynamic curtain wall testing, everything passed. So the non-rated area and the fire rated area look the same. This is the Cortland in New York City. This was a project where, due to property line proximity and air rights, one of the facades needed to be fire rated. After this project was awarded, it turned out that scaffolding was not able to be used on the project, and everything had to be installed from the inside, and they were able to do that without any problem. It has the same high performance low E as the rest of the non-rated areas and meets all the same energy requirements. Another project with property line requirements is 1 Sullivan Place. This is a fairly new project. Due to, again, air rights of the neighboring building, part of the facade needed to be 1 hour rated. Again, it was important for the energy standards to meet the same as the non-rated areas and to have a similar look to the punched opening windows, and we were able to achieve that in a 1 hour fire resistive exterior wall. Okay, now we're going to look at some multifunctional fire rated products. Again, that's where it's fire rated first, but then has another performance characteristic. This is the VA Orlando Medical Center. This is a 2 hour fire resistive and hurricane rated curtain wall. This is tested to the TAS 201 and 202 and 203 standards, which is large and small missile standards, the uniform structural load, and the uniform cyclic pressure test standard. So basically meeting those hurricane ratings. It also incorporates a high performance, energy efficient glazing. This project was unique as that it was factory glazed and then shipped in modular units for an easy installation. This is a fire and blast rated, again, similar to the last one where it is a government project. This is an Army hospital. This is a critical facility. So a lot of the blast hazard mitigation was required. The whole facade isn't the fire rated, but that 45-foot canted curtain wall is a 2 hour fire resistive blast rated. Again, the same high performance low E with the reflectivity was used on the rated areas as well as the non-rated areas. Getting a little more intense is the fire ballistic and force entry rated. This is the Plaquemines Parish Detention Center in New Orleans, and this was damaged by Hurricane Katrina and needed to be rebuilt through using FEMA funds. The new design called for 45-minute wire-free level 3, UL level 3 ballistic, and also ASTM F1915 grade 2 force entry. So that control center now has clear sight lines into the areas that they are monitoring. This is a fun project. This is the fire rated floor. This is the Union Square station in San Francisco. It's a fairly new project. It's a new subway station. The architect envisioned artistic glazing on top, allowing light to travel down into the subway station. It's a fire resistive floor. It's 2 hour. It's modular and top loaded for easy installation. It's also USA made, meeting all the Buy American requirements for the project. The floors were used throughout the subway station. Also, the elevator enclosures are rated. This is a security feature allowing visual connection to the elevators. This is the 21C Museum Hotel in Nashville. This is a 1-hour fire-resistive floor. It has a non-slip rated low iron tempered laminated glass. It features a glass floor on the second level that acts as a light well, bringing light down into the lobby. This is the largest tested and listed individual glass panels in a fully supported and butt glazed application. It comes in up to 2-hour fire resistive floor. This concludes the CE portion of the presentation. If you have any questions regarding fire rated glass, I'm here to answer them for you.
Oh, so speedy, I didn't have time to launch the poll. I am going to launch the poll right now. Do you
Okay.
have any other notes about like safety and that are not part of the AIA presentation while I launch it?
I do, but I feel like the video are very glitchy. So I'd probably save the sanity of the attendees by not showing it. I felt like the videos were very glitchy, and for that, I apologize.
No worries at all. Okay, well, I'm going to leave this poll open. Give me
Okay.
just one sec to pull up something else too as well.
Okay. Thanks. Sorry about that. We tested it and I felt like everything.
That is A-okay.
All right.
Quick presentations are great. Sorry.
Yes.
Give me just one sec to pull up
Okay.
something.
Wow, that was really fast.
I know. I was going to launch the poll in a few more minutes here. You sped through it. I did actually receive a question the other
Okay.
day in regards to like how you can help with the design process and lead times. It was a very general question that we received on the platform.
Of course. So we are happy to do design assistance. We can do budgeting, design assistance, custom details all ahead of time with no charge, obviously, to anybody. If we have what we found that we've been having some success with is, I don't know if any of architects are in California, but we do a lot of DSA non-deferred submittals up front where it allows a quicker, I guess, lead time once the project is awarded and is starting to be built. So we can assist with non-deferred submittals.
Got it. Perfect.
Yep.
I am located in California, so that's very helpful to know.
Yes.
And then your fire rated glass can achieve both the fire ratings and impact safety ratings.
Yes. Yes.
Okay, perfect. One more question here for
Of
you.
course.
What's the maximum size available for the 90-minute fire rated glazing?
So 90-minute, we don't see 90-minute walls very often. I don't think I've ever seen a 90-minute wall, but all of our glass has different max sizes. I want to say the 90-minute is 4,952 square inches, 124 inches in either direction, but not to exceed 4,952 square inches.
Okay, perfect. Any last notes? That was all the questions on my end about safety or where to find you guys while everyone finishes wrapping up the poll.
Our website is a great place to find details, product data, who to connect with. But yeah, you can reach out to to anybody here at Safety, and they can get you to the appropriate, whether it's an estimator, architectural rep, technical rep. Yeah, we're here to assist.
Okay, awesome. Thank you so much.
Yeah, thank you.
I think people are still filling out the poll, so I'm going to give them a little more time to do that before we end today's presentation.
Great. Thank you.
Yeah, of course. Anyone else that would like to get connected with Safety First after today, feel free to fill out the poll. I'll keep it open for just another minute. And then what you'll see, I know a lot of you guys have attended these webinars before, is an open conversation on Acelab with anyone from the team, and you're able to ask direct questions in there, receive product specific support and project specific support. So with that being said, I am going to end that poll just about now. Oh, we're
Great.
still getting some more people putting
Okay.
stuff in. Yeah, I would have launched it earlier. My apologies. Okay, anyone else here? I think we're good. If you didn't get to fill out the poll, there's also a survey at the end. Feel free to drop any questions in there as well. Okay, thank you
Great.
so much for today's
Thank you.
presentation,
All
and
right.
I hope you have a great day.
You too. Thanks, everybody. Thanks.
Bye.
Bye.